video presentation for the Programming with C project. This project required a script that would find solutions to differential equations. So my approach on this was basically creating uh, 4 different floats which would store um, the first coefficient, the second coefficient, and then both the initial conditions for the differential equation, which would be y of 0 and y naught of 0. And then I also created floats for example, L would be the variable for the complex case of the exponential coefficient. Then L1 and 2 would be basically the exponential coefficients 1 and 2. Then I created C1 and C2 as variables for their real and also for the repeating answers. Then C and theta are both for the complex case in particular. Then also created 3 user-defined functions that would take in different values basically. It would take in I1, I2, L1 and L2, and then it would give back basically the different values that we're going to need: C1, C2, C and theta, L, L1 and L2. Then in the main function I prompted the user to type in the different coefficients A1 and A2, also the initial conditions, and then I stored them with the scanf function. And then here in this part I'm calling a header file called quad eq.h, then get carb and return 0. So let me go to the next slide. Here I'm defining the user-defined functions basically. As you can see here, I solve for C1 and C2 using the inputs as E1, E2, L1 and L2. Then I return these 2 values to the main function. Same here, but in this case for the complex solution, and this case for the repeating solution. Then inside the header file called quadeq.h, I used an if statement, else if statement, and else statement for the 3 different cases. And then I used the determinant here. Basically, if the determinant is greater than 0, then you would have real solutions, and then you would get a value for L1 and L2, and then you would print the general form of the response. And then inside that if statement, you would call the user-defined function that we saw in the previous slide, called the real solve, and then I1, I2, L1 and L2. Then you would print the actual solution. You would do the same for else if, and then this case would be when it's complex. It has a complex solution because it would be, the determinant would be less than 0. Then here you would say that L is basically minus A1 over 2.0, and that would be the value assigned to L. But then you also need a complex part, right? L would be the real part of the complex solution, and then you would need a imaginary part, which I define here to be J1. And then after getting that, we would do the same steps basically. Print the general form of the response, then call in the comp solve, to solve the complex, to get the complex solution, and then you would print that solution. Same with else, which is the case when L1 is equal to L2, basically the determinant is equal to 0. So then for the second part of the project, I basically declare the same variables for this part, then the same functions, user-defined functions, but then an f input float was needed. I set it to 0 to basically temporarily store the valuables I will get later on from the file. And then rows is also needed. Basically, you would store the row number, and then columns would store the column number. Then I created an array called numbers to store the values obtained from the file. Then in the main function, I actually create a pointer called data and then open the data the text file for reading purposes. And then I use a while loop to basically get values from data and temporarily store them in the float f input. This happens until the end of the file. So basically, then each f input will be stored in the permanently in the array, in the defined array. And then I actually do print all of the array, basically all of the values in the array. And then I close the file using the fclose function, and then call in the coefficients, which is also a user-defined function that I define here to be a void. And then inside the coefficients, as you can see, this other three user-defined functions are from same ones as the previous one. The only thing that changes is that I actually have this void coefficients, and inside void coefficients I open the result file for writing, basically. Declare a float, um, declare a pointer for result, and then open the text for writing. Then also create integers I and j for them to be used in the for loop, basically. Then I do the for loop. Because I'm basically creating my script to solve 4 differential equations, I used I less than 4 here, but it can be changed, so it isn't too much of a big deal. And then I have another for loop here to store the values from the matrix, basically from the array, into each particular A1, A2, I1, and I2, and for those values to get stored, basically get the values from the array. Then down here I actually call the header file into the main function to compute the needed values. Then I create 3 arrays to actually one of them called decision to store the type of solution, and then one array to store the constant 1 or the constant for a complex solution, and then the last one to called constant 2 to store either constant 2 or the angle for the complex solution. Then I use again if, else if, and else statement, basically to assign values to these arrays. If basically the determinant is greater than 0, that means we have real solutions. So decision would be 1 basically, and then the constants would be C1, and then constants 2 would be C2. If that's not the case, then the power, we will check if power A1 squared minus 4A2 is equal to 0. Basically the determinant is equal to 0. That would mean that we have repeating solutions case, and then the decision would be 2, the constants would be C1, and constants 2 would be C2. Else, then it would be complex solutions case, and decision would be 3, constants 1 would be C, and then constants 2 would be theta. And then basically I'm doing an fprint f part here, which will copy the results into the result file, and then the computation and decision maker will be done 4 times because of the for loop. First row for equation 1, second row for equation 2, and so on. First column for type of solution, and second for constants, C1 or C, and then third for constant C2 or theta. Then I'm doing the fprintf here, basically. Fprintf result, percentage f, comma, percentage f, comma, percentage f, then decision I, constants 2I, which will basically print my results into the result file. And then I close the result file. Learned in this project is basically I managed to get a lot of understanding on how user-defined functions work, on how to access files, and basically how to get values from the file, read them, and then basically do some computations with those values, and actually getting the results pasted onto another file. I think that was really useful. The most difficult challenge was not even accessing the file, getting the values from it, and do the computation. What I struggled the most with was basically pasting those values, getting those values onto the result file. For some reason, which I don't know why, I was basically getting four times the same the same case, the same differential equations. Instead of getting the solutions for four different differential equations, I was getting stuck on the last one, and that last one was getting pasted four times. So what I noticed that the problem was, it was not even me accessing the file, you know, for writing. Nothing wrong with the syntax. It was that I had another for loop added in the end that was causing around here. It was causing for the value basically to be stuck on the last one, and then the last one being repeated. So I basically deleted that for loop because it wasn't unnecessary, and that solved it completely. And I think that I was stuck on that for like a day and a half. And my opinion on this project, I think it was very educational and very fun to do. Honestly, I just, you know, got mad at some point because I couldn't figure out what was wrong with it. But it was really, really educational, and I'm glad I was able to do it. So yeah, that's it. Thanks.